In the context of optional calculations for multifamily dwellings, specifically concerning NEC 220.32 ATWO, the question arises regarding the treatment of an electric oven when a dwelling unit is equipped with both the gas range and an electric oven. The primary concern is whether the electric oven qualifies as electric cooking equipment and how its load should be incorporated into the overall electrical load calculation. An electric oven is indeed considered electric cooking equipment, provided it is designed and intended for cooking food. This determination is based on its function and purpose within the dwelling unit. When performing the optional calculation for a multifamily dwelling, if the unit contains a gas range and an electric oven, there are two options for calculating the electrical load associated with the cooking equipment. Firstly, you can utilize the actual nameplate rating of the electric oven. This method involves identifying the kilowatt rating of the oven as specified by the manufacturer on the appliance's nameplate and incorporating the value directly into the load calculation. This approach is straightforward and reflects the actual power consumption of the installed electric oven. Secondly, you can apply the 8 kilowatt exception as outlined in NEC 220.32 APWO. This exception provides an alternative approach to calculating the load when no electric cooking equipment is present. However, it can also be used when there is a combination of gas and electric cooking appliances. The rationale behind this exception is to account for the potential future installation of electric cooking equipment. Even if the dwelling unit currently has a gas range, the 8 kilowatt allowance ensures that the electrical system has sufficient capacity to accommodate an electric range if one is installed later. The decision to use either the actual kilowatt load of the electric oven or the 8 kilowatt exception depends on several factors, including project specifications, local codes, and design considerations. If the primary goal is to minimize the calculated load and the electrical oven has a nameplate rating significantly lower than 8 kilowatts, then using the actual kilowatt rating of the oven may be advantageous. Conversely, if future flexibility and potential upgrades are a priority, applying the 8 kilowatt exception may be more appropriate. To clarify the application of NEC 220.32 ATWO, let's consider a hypothetical scenario. Suppose a dwelling unit in a multifamily building has a gas range and an electric oven with a nameplate rating of 4.5 kilowatts. Using the first option, the load calculation would include only the 4.5 kilowatt load of the electric oven. However, using the second option, the load calculation would include the 8 kilowatt allowance, regardless of the actual oven rating. Understanding the nuances of these options is essential for accurate and code-compliant electrical load calculations in multifamily dwellings. In summary, when calculating the electrical load for a dwelling unit with a gas range and an electric oven under NEC 220.32 ATWO, you have two choices: use the actual kilowatt load of the electric oven only, or apply the 8 kilowatt exception. Both options are valid, and the appropriate choice depends on the specific requirements and design considerations of the project. Electrical load calculations are crucial for ensuring the safety and reliability of electrical systems. They involve determining the total electrical demand that a system or device is expected to draw. This calculation is essential for selecting appropriately sized circuit breakers, wires, and other electrical components to prevent overloading, overheating, and potential fire hazards. The National Electrical Code, or NEC, provides guidelines and standards for electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in technology and safety practices. Electrical load calculations are governed by various sections of the NEC, including Article 220, which covers branch circuit, feeder, and service calculations. In multifamily dwellings, the electrical load calculation becomes more complex due to the diversity of appliances and equipment used by different residents. To simplify this process, the NEC allows for optional calculation methods, such as the one described in NEC 220.32 for multifamily dwellings. NEC 220.32 provides a simplified approach for calculating the service and feeder loads for multifamily dwellings. This method takes into account the diversity of loads and the likelihood that not all appliances will be in use simultaneously. The optional calculation method typically results in a lower calculated load compared to the standard calculation method, which can reduce the overall cost of the electrical installation. However, it is essential to ensure that the calculated load is still sufficient to meet the actual demand of the dwelling units. The 8 kilowatt exception mentioned in NEC 220.32 ATWO is a specific allowance for cooking equipment. It recognizes that not all dwelling units will have electric cooking equipment, and even those that do may not use it continuously. By allowing for an 8 kilowatt load, the exception provides a reasonable estimate of the cooking load without overestimating the total demand. When applying the 8 kilowatt exception, it is important to consider the specific characteristics of the dwelling units. For example, if all the dwelling units are known to have gas ranges and only a few have electric ovens, it may be more appropriate to use the actual kilowatt rating of the electric ovens rather than applying the 8 kilowatt exception to all units. Conversely, if there is a high probability that many units will eventually have electric ranges, applying the 8 kilowatt exception may be more prudent. In addition to cooking equipment, other loads must be considered in the electrical load calculation for multifamily dwellings. These include lighting, receptacles, heating, ventilation, and air conditioning, or HVAC, equipment, and other appliances. Each of these loads must be calculated separately and then combined to determine the total load. The NEC provides specific guidelines for calculating each type of load. For example, lighting loads are typically calculated based on the square footage of the dwelling unit, while receptacle loads are calculated based on the number of receptacles. HVAC loads are calculated based on the size and efficiency of the equipment. It is important to note that the electrical load calculation is not a one-size-fits-all process. The specific requirements and conditions of each project must be considered to ensure an accurate and code-compliant calculation. Consulting with a qualified electrical engineer or contractor is highly recommended, especially for complex projects. In addition to the NEC, local codes and regulations may also affect the electrical load calculation. These codes may impose additional requirements or restrictions that must be followed. It is essential to be familiar with all applicable codes and regulations before beginning the electrical design process. Accurate electrical load calculations are essential for ensuring the safety and reliability of electrical systems in multifamily dwellings. By following the guidelines and standards provided by the NEC and local codes, electrical engineers and contractors can design systems that meet the needs of residents while minimizing the risk of electrical hazards. Furthermore, understanding the nuances of optional calculation methods and exceptions, such as the 8 kilowatt allowance for cooking equipment, can help optimize the electrical design and reduce overall costs. Therefore, a comprehensive understanding of electrical load calculations is crucial for anyone involved in the design, installation, or maintenance of electrical systems in multifamily dwellings. The NEC is a comprehensive document that covers a wide range of electrical topics. It is organized into articles, sections, and tables that provide detailed requirements and guidelines. Navigating the NEC effectively requires a thorough understanding of its structure and organization. Article 90 of the NEC provides an introduction to the code and outlines its purpose and scope. It also defines key terms and concepts that are used throughout the code. Article 100 defines the terms that are used in the NEC. It is important to consult this article whenever you are unsure of the meaning of a particular term. Article 200 covers the use and identification of grounded conductors. It specifies the requirements for grounding electrical systems to protect against electrical shock. Article 210 covers branch circuits, which are the circuits that supply power to outlets, lighting fixtures, and appliances. It specifies the requirements for the number of circuits, the size of conductors, and the overcurrent protection. Article 215 covers feeders, which are the circuits that supply power from the service entrance to the branch circuits. It specifies the requirements for the size of conductors and the overcurrent protection. Article 220 covers branch circuit, feeder, and service calculations. It provides the methods for calculating the electrical loads that are used to determine the size of conductors and overcurrent protection. Article 225 covers outside branch circuits and feeders. It specifies the requirements for the installation of electrical conductors and equipment outdoors. Article 230 covers services, which are the conductors and equipment that connect the utility power supply to the building's electrical system. It specifies the requirements for the size of conductors, the overcurrent protection, and the grounding. Article 240 covers overcurrent protection, which includes circuit breakers and fuses. It specifies the requirements for the selection and installation of overcurrent protection devices. Article 250 covers grounding and bonding, which are essential for protecting against electrical shock and fire hazards. It specifies the requirements for grounding electrical systems and bonding metal parts to create a low impedance path for fault currents. Article 300 covers general requirements for wiring methods and materials. It specifies the requirements for the installation of electrical conductors and equipment. Article 310 covers conductors for general wiring. It provides the ampacity ratings for various types of conductors. Article 400 covers flexible cords and cables. It specifies the requirements for the use of flexible cords and cables in electrical systems. Article 406 covers receptacles, cord connectors, and attachment plugs or caps. It specifies the requirements for the installation of receptacles and other wiring devices. Article 408 covers switchboards and panel boards. It specifies the requirements for the construction and installation of switchboards and panel boards. Article 430 covers motors, motor circuits, and controllers. It specifies the requirements for the installation of motors and motor control equipment. Article 440 covers air conditioning and refrigerating equipment. It specifies the requirements for the installation of air conditioning and refrigerating equipment. Article 500 covers hazardous, classified locations. It specifies the requirements for the installation of electrical equipment in hazardous locations where flammable gases, vapors, or dust may be present. Article 517 covers healthcare facilities. It specifies the requirements for the installation of electrical systems in healthcare facilities. Article 547 covers agricultural buildings. It specifies the requirements for the installation of electrical systems in agricultural buildings. Article 550 covers mobile homes, manufactured homes, and mobile home parks. It specifies the requirements for the installation of electrical systems in mobile homes and manufactured homes. Article 600 covers electric signs and outline lighting. It specifies the requirements for the installation of electric signs and outline lighting. Article 625 covers electric vehicle charging systems. It specifies the requirements for the installation of electric vehicle charging systems. Article 680 covers swimming pools, fountains, and similar installations. It specifies the requirements for the installation of electrical systems around swimming pools and fountains. Article 690 covers solar photovoltaic, or PV, systems. It specifies the requirements for the installation of solar PV systems. Article 700 covers emergency systems. It specifies the requirements for the installation of emergency electrical systems. Article 701 covers legally required standby systems. It specifies the requirements for the installation of legally required standby electrical systems. Article 702 covers optional standby systems. It specifies the requirements for the installation of optional standby electrical systems. Article 705 covers interconnected electric power production sources. It specifies the requirements for the installation of interconnected electric power production sources. Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power limited circuits. It specifies the requirements for the installation of Class 1, Class 2, and Class 3 remote control, signaling, and power limited circuits. Article 760 covers fire alarm systems. It specifies the requirements for the installation of fire alarm systems. Article 800 covers communication circuits. It specifies the requirements for the installation of communications circuits. Article 810 covers radio and television equipment. It specifies the requirements for the installation of radio and television equipment. Article 820 covers community antenna television or CATV and radio distribution systems. It specifies the requirements for the installation of CATV and radio distribution systems. Article 830 covers network power broadband communications systems. It specifies the requirements for the installation of network-powered broadband communications systems. These are just a few of the many articles covered in the NEC. It is essential to consult the NEC whenever you are designing, installing, or maintaining electrical systems to ensure that you are following the latest safety standards and requirements. In addition to the articles, the NEC also includes numerous tables that provide detailed information on conductor ampacities, conduit fill, and other important parameters. These tables are essential for performing accurate electrical calculations and selecting the appropriate materials for electrical installations. Understanding the structure and organization of the NEC is crucial for electrical professionals to ensure safe and compliant installations.